All right, guys, we're going to be in, we're still in unit 4 right now, and that's functions, and their inverses. That's what we're doing now. Okay. So the essential question is, how can I write one function that is made up of pieces of different functions? So that's the question, the essential question. How can I write one function that is made up of pieces of different functions? So basically, what we're talking about today is piecewise functions.
So we got them the whole bag?
No. So we're talking about piecewise functions. So what is a piece? I spelled this a little wrong here. So what is a piecewise function? A piecewise function is functions that combine several pieces that each of them have their own equation and domain. So the important thing you have to remember, each of these functions, it can be two or more, they have their own equation and they have their own domain. Okay, so we'll talk more about that. So first thing I want to do is write down an example of a piecewise function, and I'm going to graph it. So we haven't talked about graphing piecewise functions. I just want to go ahead and do that right now. So this is an example of a piecewise function. F of x is equal to, so a piecewise function has two or more functions. And this is sometimes say f or when x is less than or equal to 2 and f x is greater than 2. Okay. So this part of the function is called a domain. Okay. So this says that if you plug in input x, if it's less than or equal to 2, then this is the function that you use. And if you plug in x and it's greater than 2, then this is the function that you use. So you basically have two functions that are into one. You can actually separate these functions, but the reason why they're called piecewise functions, you can have 2, 3, 4, 5 functions in one function. So let's go ahead and show you how to graph this. So we have let's do a table of x, a t table, a table of values. And have x here, f of x here, and this is y, same as y. So let's take that first one here. It says x is less than or equal to 2. So we're going to actually do both of these functions on one table here. So it says let's do this first function, which is right here. X is less than or equal to 2. So let's put 2 here, and let's just put some points that are less than 2, okay? So let's plug x in to this function. So if I plug in 0 here, I'll have minus 2 times 0 minus 1. So that'll be 0 minus 1, so that'll be minus 1. When I plug in 2 for x, I'll get 2 times 1 minus 1. That's minus 2 minus 1 is minus 3. And when I plug in 2 there, I'll get minus 2. 2 minus 1 is equal to a minus 5. So these are my points that I can graph for this first function. So let's go ahead and graph that. So I have, if x is 0, y is going to be minus 1. So x is 0, y is a minus one, so that's gonna be right there, okay. So it says x is one minus, y, f of x is three. Is that right? Minus three, I'm sorry. So, y, and right there. And then it says if x is two, then f of x is minus five. So that's gonna be somewhere right here, okay. So you can actually connect this here. So this is the domain. Domain, you can just, if you wanna emphasize the domain, what you can do, sometimes you can just realize this is a domain here. Put a dotted line. It means this function doesn't go beyond 2. It says less than or equal to. Now, because it says less than, then I have to put a solid dot. If it just says equal to, I have to go. It doesn't include. So this function includes 2. So I have to put a closed dot here. Okay. All right. So let's graph that other function here. So it says x is greater than 2. Now we can still include 2, but realize that we don't. It's not a part of the equation. You know, we still can include it. So you can leave it out, but we would include it. But it doesn't. This says x is greater than 2, so it's not gonna include 2, but we can still put it down. This is 2, 3, and 4. Let's go. So we're doing this equation here. So minus 2 plus 4 is equal to 2. If I plug in 3, minus 3 plus 4 is equal to 1. And I'll plug in 4, so x is greater than 2, minus 4 plus 4 is equal to 0. So we have our x points and f of x points. Let's go ahead and plot this one. So this one says that x has to be greater than 2. And if x is greater than 2, then f of x is equal to 2. So it'll be 2 and 2. So notice there has to be a 0 here, a closed dot, because it doesn't include. And then when I plug in 3, I get 1. So if x is 3, then y is 1. And then x is 4, y is 0. Okay, so this function goes this way. So this goes to a negative infinity, and this goes to a positive infinity, okay? So this is a piece where I just basically grafted 2 functions into one graph. And realize this is the domain here. That this function doesn't go beyond this point. And so this function, when it goes here, it jumps up to here. This is a closed function because it doesn't include 2, and it goes to negative infinity. So that's how you graph it. Okay, does everybody kind of understand that? Yeah. All right, so let's do something like your delta math will be on evaluate a function. So let's go into that. So everybody understand this now? Yes, you have a question?
You want me to do that graph right there?
Do I want you to do it? I want you to understand it. Do you understand what I did? So I just basically took these two functions and put in the x value. I made a t-table. You guys know how to do this. I just substituted 0 for x, 0 for 1, and 0 for 2, and I just came up with this line here. Then I took the second equation. It says x is greater than 2, so I used 2, 3, and 4 because x is greater than 2. It's not equal to 2, but it's greater than 2. But I still use 2, and then I plugged it into that equation, and I got if x is 2, then y is 2, x is 3, y is 1, x is 4, y is 0, and I plotted it. But since this says x is greater than two, it didn't say it was greater than equal to, then I had to make it, open circle. I can't close that circle in, because x does not include two, okay? So, you need to kind of understand this graph. Any other questions? Let me do piecewise, about how do you evaluate a piecewise function? Sorry. Okay, so this is evaluate a piecewise function. Okay, so we have let me draw a piecewise function here. So this time we have three functions in one. We have f of x equal to 12 if x is less than minus 3. So if and only if whatever x is, if it's less than minus 3, then this is the function of f of x equals 12. This is 15 if x is between, if f is less than 6, but greater than or equal to minus 3. And this is 20. How am I doing on time? 3 minutes. If x is greater than or equal to 6. Okay, so when you get when you have to evaluate a function, you're gonna get something, you're gonna get a function with the x value already in it. Let's evaluate three functions here. Okay, so I'm gonna evaluate three of these functions here. So this says, when I substitute minus 1 for x, which one of these domains do I have to use? So x is minus 1, which one of these domains is minus 1 in? The first one, the second one, or the third one?
Second.
Why is on the second one? First, second, third. X is equal to minus 1. Look at the domain, guys. Domain is here. So this tells me which one of these equations I have to use. So if x is minus 1, which one is I have to use? Fabian, which one do I have to use? Not sure. So it says here x is less than a minus 3. You can't use this one because it says x is greater than 6. Obviously minus 1 is not greater than 6. You wouldn't use that one. This says x is less than 6 but greater than or equal to 3. You can't use that one. The only one you can actually use is this one. You have to use that one. So when you use that one, they say the answer is 12. So that's going to be 12. All right, what about this one, guys? F of x is 3. Which one do you have to use?
Number 2.
Oh, wait a minute. Let me check something, guys. Make sure that's right. Oh, that's not right. I'm sorry, I made a mistake. Which I do occasionally. So who said 2?
Me.
You're right. I'm sorry. You're right. I'm sorry. Minus 1 is, x is, wait a minute, is that right? Or did I do the wrong thing? Let me make sure I did this right. Yeah. Minus 1 is greater than minus 2, minus 3. So it's going to be this one here. Sorry, guys. Okay, what about this one? F of x, f is equal to 3. Which one would that be? Well, you know it can't be that one because this is x is less than minus 3. So that's going to be minus 4, minus 5, minus 6, minus 100. So it can't be that. You can eliminate that. Can't be this one because it says x is greater than 6, so it can't be that one. So it has to be this one again. Does that make sense? Okay, the domain has to be that one. Again. Okay, so this says f is equal to, wait a minute, I made a mistake on this one again. Let's say this is 8. So which one would be first, second, and third?
Next document, quick, sir.
Hmm?
Next document?
Yeah. First, second, and third.
You said what?
Which function would this be? F of x is a, which function would it be? First, second, and third? Third, okay. Yeah, because whatever x is, it has to be greater or equal to 6, so it has to be this function, so that's gonna be 20.
What little sign off thing?
Hmm?
The little sign off sheet.
Right over there.
Right. Right.
All right, does everybody understand that? Yes. Okay. Everybody understand that? Okay.